Bought a Carver C2000 off of eBay, and even though it's got a lot of fragile stickers on it, got a big hole in the side of the box. So we'll have to check it out here and see if it made it in one piece. It's a for restoration unit. The box got pretty beat up, so we'll take a look at it and see what shape it's in. So the shipper did a real good pack job on it, and physically it arrived in one piece. We're going to take the covers off and go through every one of the boards. All the controls need attention. We're going to have to clean all those out and do a visual inspection on all of the boards, but it did arrive in one piece and it's all here. Every one of these switches is separated. So what I do is I pull all the switches. You can see the outside comes off. It's not glued to the inside anymore. I bag them all. So I take a little piece of cardboard, wrap it in tissue paper, and then I'm able to get underneath it. Pull it off. So take every switch off and bag them first. Okay, so all the knobs are off. They're all bagged and tagged. Next thing we'll do is pull the side, top, and bottom covers. Okay, got the cover off. And here's a first look at the inside. It's pretty dirty. I mean, I've seen a lot worse. There's a lot of conductive glue around the caps. So a lot of sawdust in here too. I'm not sure exactly where that came from. The side panels are particle board. They're not in great shape. I don't see any hot spots, but there's a lot of this conductive glue. So I may remove the electrolytics and clean off all that glue. But don't see any hot spots per se. So I'm going to take it all apart, pull the caps, clean the glue off, dust it off, and then we'll take another look at it. Okay, I'm going to blow this out. Clean, dry, filtered shop air. Things are an absolute mess. So we're going to clean off every board. This one was covered with a lot of sawdust, or I'm not sure what it was, but if you got a match, now's probably a good time to use it, because it will at least stop chunks this big. Okay, I'm going to flip it over, get the bottom side and all the controls. There's the bottom of the unit. It's pretty clean compared to the top, and there's still a lot of dust. There might be a couple hot spots in the power supply area. We'll check that out closer. I pull the cover on the transformer just to look for corrosion, oxidation, burning, and it looks absolutely perfectly clean. Okay, so that's the triac. And right there, those are the triac terminals. And I just ohmed that out. There's no shorts there, so the triac looks good. There's a big inductor next to the triac, and it's just coated with that resistive conductive glue, as well as around these electrolytics. It's just black. I don't know if you can see it. Over here too. So we are going to replace these electrolytics because they're old. Even if they test good, they could be dried out. I'd rather replace them now than have them blow. Okay, so I'm in the process of cleaning up the power transistors where they mounted to the main power amp board. There was just an absolutely massive amount of flux that had all turned really dark. I cleaned the other side off. That's what it looks like before I clean it. and that's what it looks like afterwards. Okay, I checked the triac, which is good. I pulled some of the electrolytics and tested those and cleaned off the gooey paste and the glue, and that looks good. Checked the power transistors, they all look good. Checked the drivers and they look good. I brought it up, not turned on the variac, no excessive current draw. Let's just take a look at the startup voltage on the power regulators. And that looks good. So the standby voltage is there. Okay, next thing we're going to do is turn it on and see if there's any excessive current draw. Okay, the unit is powered up, drawing less than an amp, which looks pretty good. See if we got high voltage. We have high voltage. Yep, everything looks good. The next thing we're going to do is hook up a headphone. Since the headphone is powered by the power amp that goes through an attenuator, and see if we can hear anything. Okay, the unit's powered up. I can hear sound through the headphone. There was some slight distortion on the right channel, and when I do the pencil tap in this area of the board, I can get some distortion and make it go away. So I'm going to look at the schematic, see what's specific to the right channel, and see if I can narrow that down. And now I got a bunch of knobs here that are broken. I am going to glue those knobs back up that I'm missing. So on these factory knobs, they had split in half, like this one. The inner and outer had come apart. So all I do is clean them off with alcohol and then push them back together. I picked up this Carver C2000 as a distorted sound, one channel out unit. Took it all apart, cleaned it out, cleaned all the controls, replaced one cap, bad solder joint, adjusted the power supply, bias voltages, cleaned up the side panels, put it all back together, and I think it's okay. So after I got this all cleaned up, new cap, fixed all the solder joints, I was still having an intermittent, and I went probing around, and I noticed that when I added 10 puff to Q706, I could get it to start up pretty much every time. So I figured it was Q706, and so I figured I'd replace the pair of 706 and 708. So 706 and 708 are a 2SA 1360 and a 2SC 3423. They're the Y yellow gain versions. Closest cross I could find are these on semi-transistors that are also both obsolete. I did find some of these available, the Y version. They came from a reputable supplier, and they are the Y version. So there's the original transistors that I pulled out. You know, they don't measure too bad. So what I ended up with is 4 of the PNPs. I characterized all those. 2 of the NPNs, I characterized those. I tried to pick the pair with the closest VBE match. The HFEs, the gains were matched pretty close, a lot closer than the originals. The VBEs were a little bit wider, but I put them in, and let's fire it up. So it comes up every time, so I think we got it. It was that Q706 and Q708. But wait, there's more. So after I got this thing all put together, I realized it doesn't switch between AM and FM. So I can switch to AM, but then it doesn't switch back to FM. So I tracked it back, and I can actually, there we are. It's the switch. So it's an ALP switch rated for 500,000 cycles. That same switch is used in numerous synthesizers from back in the day. I did find a bunch of tactile switches. I have some on the way. And when they get here, we'll take this thing apart. Basically, you pull the bezel off the power meter, take off all the top and bottom screws. The front panel will come back, and then we can get the board out that contains the FM AM switch, and we'll put some new tactile switches in there and see if we can fix it. So I'll see you when the switches arrive. Okay, the switches came in. There's the package, and there's the switches. So the first thing we're going to do is pull off the power meter bezel. It's a 2mm Allen wrench. Takes these 4 screws out. Then we're going to take the top and bottom screws out, 3 on the top, 3 in the bottom, and that will allow the whole faceplate to come forward. Once that happens, we'll be able to get access to the AM/FM switches in the rear, and I'll show you. We're going to free up that PC board so we can pull out the FM switch. Okay, so there's the PC board. The panel is pulled out. There's the PC board we need to separate. We need to take this Allen screw out first, and then there's a tab. You have to very carefully push that tab over, and then the PC board releases, and once that does, we can pull it out and replace the switch. To pull that Allen screw out, we're going to use this curved offset screwdriver. Okay, I measured the switches, and they are dimensionally exactly the same, width, length, and height. So those should work. I am going to put a little color dot on there just to make sure I get the orientation right, but let's take the left switch out, the FM switch. Okay, so what I'm going to do is put the board on top of this piece of cardboard, and then I am going to use my desoldering gun to desolder that switch and pull it off the board. Okay, I hate surprises, so I did take the switch and check both sides, double pull, single throw, and it works. The switch is out, came right out. There's the old switch, and now we're going to put in the new switch. There it is. New switch is in. Desoldering machine is off. We're going to go ahead and solder that up here. Get the soldering iron going. Okay. Give that a minute to heat up, and we'll solder that right in. There it is, all soldered up. We're going to get the board back in and reassemble it and see how it works. Okay, front panel's on, screws are not tight. Before we commit ourselves, let's make sure this works. Unlike last time. Okay, power's up. We're on AM. Alright, FM, AM, FM, it works. Success. Let's button this thing back up and put it into service. Okay, so there it is. Covers are back on, side panels are back on, it works. We fixed the audio, bad transistors, bad switches. Everything is functional, 100%. We're going to go get it back into the cabinet, hook the equalizer up, and bring it for a test drive. Okay, so that's the switch that came out. The one that was rated for 500,000 cycles. And both sides of the switch are bad. They're open. So I'm not going to take it apart and figure out what went wrong, but anyways, fortunately it was an easy fix. There it is. It's back home in its rack. It sounds great. I'd play it for you, but I don't want a copyright strike. And I got it hooked up to the AR9s, and it sounds great. That's it. This is what it's replacing. It's an MXR 130, and that's going off to the bench for some mods and some updates.